I don't know. I usually know you're here. You can look on my OTC at that thing, that grade book thing. No, it's like illusion or something like that is the one we have to use for attendance. Do you know how to go to your attendance? Can you show him on my OTC? Because I don't know how to get there. You guys get there.
Why not do it using Pinnacle? Do you mean using
Pinnacle? Yeah, using Pinnacle. That's the thing. That's what it's called.
That's what I'm saying. I do it on Pinnacle. You know how to get
yeah.
Pinnacle? All right, let me get you the site real quick. Just Google Pinnacle.
Oh, and that works. Usually when I can't remember how to get to it, I can't remember it's called Pinnacle either.
Yeah, you guys stopped using that a couple years ago, right?
Well, there's just a whole bunch of teachers that won't go to Canvas, so they just keep keeping it.
I mean, that class is complicated, and the answers you answer are going to be kind of complicated. People wouldn't use Canvas because a lot of the answers wouldn't kind of right. If you did, you had to put them all into the cell. You had to go for it to work like you wanted it to. Yeah, he was also curving his grade down by like 20% from what MSU wanted it to, and he needed like more than what Canvas would do.
Yeah, I think it has a lot of capabilities. That's why they won't switch. Pretty fancy. Let's look at our quiz and see if I can bring up that stuff. What am I looking for? Let's see if it will show us.
Hey, that's not too shabby.
Not too bad.
I mean, that looks
Let's see if we can.
But like you said, for this.
Yeah, for this course, and this is our hardest exam that we have. It seems to be. Yeah, this is the hardest one. Right, it's just a hard one, and it's got a lot of the fill in the blank ones that are pretty wide open.
All right, now whether you learn that or not, let's build on it. Yeah.
Now remember, this one we had a couple of Kahoot's questions on that. We had 3 people that got this question, and because it's a fill in the blank, it makes sense that you might not be able to remember the equal. But remember, we're always looking for 2 equal signs to see if something is the same as something else. Fill in the blank is mean. This one you guys did great on. It's a not, and it's trying really hard to be a confusing condition, so that's really good. Multiple alternative. Is the case or switch statement. Again, really good because it was fill in the blank. Hard to remember what they're looking for. Now this one, again, everybody did great. Remember when we're doing comparisons of alphabetic stuff, string stuff, this is alphabetical order. What did we decide? Were lowercase letters smaller than uppercase or bigger? Do you remember? How could you find out?
If lowercase numbers, what?
Yeah, are lowercase letters smaller or bigger than higher case? Less than? Yeah, smaller.
Less than, okay. That
Yeah,
makes more sense.
and this is the first class in a long time looking at your short answers. I sense that we do have a few people that are having trouble with the greater than and less than symbols. That's a real common problem. It's been a few years since I've had a class that had any problems with that. So if you're having issues with it, you know, review, remind yourself, how do they do that in 3rd grade? The alligator, yeah, is, you know, the mouth's open on the bigger side, and the little side is pointing to the little one.
I always remember it like if it's like this, so it's bigger, then it almost forms an L. So it's less than. And then if it's this way, it's greater than, right? It's backwards.
I don't know. I'm not going to say yes.
Backwards, that's backwards.
I'm just going to say the little side points to the little number, the big side to the big one. Okay, and so, yeah, this one looks good. This if statement. You guys are doing great at resolving these and figuring them out. This one's super complicated. Everybody did good. Let's see, what's this one? The user input for response is 3. So what would be displayed? And this one is doing a select case. So that's why we got the answer, huh? Because remember, Python doesn't have a select case statement, but we still have to be aware that they exist. So this one might be one that you want to print off or put in your notes, because it's going to keep popping up on you, because we're going to keep asking you about it to make you remember it, so you get to a language that you can use it. So if they typed in a 3 in this input statement, what would be executed there?
Right, the door to open, Sesame Street is open.
Yeah, so we'd see that case 3 and do that output. Good job. So it makes sense. It's logical. Boolean variables, very good. 2 strings are equal if they contain the same thing. The greater than or equal, we updated that question to take either relational or comparison operators. Remember, in some textbooks, they only allow relational, and you'll get it wrong if you choose comparison. So be aware of that, just different terminology in different places. The people that answered something else, double check those terms, because we got to get those down. Let's see. Pretty good. Oh, very good on answering the output. I'm just scrolling through. Here's one that we had a few people. The majority of people got it correct, though. So which of the following will test to make sure the number entered by the user into the variable names in range is between 5 and 50, not including 5 or 50? That seems wrong. Take a look at that on your screen if you're on a Zoom session. Do not get on it, but that seems wrong.
Yeah, I don't know.
The whole question seems wrong, because look, even these ones that are have the equal sign don't have the 2 equals like they should have.
That's what threw me off, and that's why I said or.
That question
I
is
said 5.
not ever popped up as being a problem, but it looks like it's incorrect.
And that's why I got it wrong.
That makes sense, yeah.
I thought, well, it doesn't have the 2 equals.
Yeah, I'll double check that one, but it definitely looks like we should all get credit for that one. Let me check it. It's a range check thing. Okay. That's a good reason for us to look at them too.
If I had an issue with one of them, I know that the reciprocal is 16 and 1/16, but the practice test and there wasn't one.
I was gonna say that too, so I didn't know that.
So, yeah, I mean, I don't
And I
have-
changed it right before the test. So if you got that wrong because of that, you can email me that question and I'll
Okay.
give it to you, because that's why I don't like to change it right before we go. But remember, always answer the right answer. Even if the practice test has the wrong one, always answer right.
I think your screen might not have just shown the greater than and less than symbols for the in range one.
Really?
Yeah, because
I'm not seeing them on my screen here either.
I have that test question on mine and I got it right.
And you're
It has
seeing stuff?
It has all the answers should have greater than or less than symbols.
Okay, so maybe it's just not showing it properly here. Okay, good, because I was like, man, surely somebody would have mentioned that one being so messed up. Good job on the pay rate. Looking again at Bunny and Buddy, my name being Bunny is less than Buddy. Is that correct? No, because we're looking for the not true. So always watch really close when we're doing these if statement ones, that they might put something like that in to make it backwards. So the people that got it wrong probably got it wrong because of that, not because it's so easy to make a mistake. This question here had to do with the logic table. Remember, if X is false and Y is false, then the not is going to switch everything around, and we're going to say true or true. And we want not on both of them. So good job on these people that said it was true. It's super confusing. So what I would do is take this and look at it without the knots. So X or Y, those are both false, so it would be false. When I put the knots in front of it, it's totally going to reverse it, so that's going to make it true. So that's kind of the easiest way to interpret those not logic bombs. So for our if statements, remember arithmetic is going to be first, and what was going to be second? Our relationships, and then finally our ors and ands, our logical operators, will be last. And we'll be doing some error checking. That was just one little weird sentence in the book somewhere. So good job. Single alternative, only an if, one single thing. I think you guys look good. I'm just going to scroll through, see if there's anything that pops out. It doesn't look like it. Yeah, a lot of these here at the end that are showing everybody got it wrong only had one person or so. So great. Let's take a look at our new stuff. Now we need to start looping.
With the test, if we got an answer and we emailed you about it, did you change those yet? Or?
Not yet. I'll send you an email back. When I get to them, I usually leave them as my lowest priority. And I've had about 100 emails since then, so I was whining to her. I'm sick of looking at emails. So we're going to look at this presentation that's at the top of our week 9 stuff, our repetition statements. The second one down is the textbooks presentation. This tutor activity, Loops with Turtle, we'll do together, probably not today, probably next time, but you can hang on to that one. Now, the Chapter 5 review questions, those are homework, so be working on them and be working on this sum of squares. Now, let me tell you a little secret about this sum of squares program. You might be able to find it almost exactly like you need it somewhere in the stuff that's been assigned to you, because some of the examples give you an example that's almost exactly what you need there. Not on purpose, but that gives you a little heads up. So I'm going to look at this presentation. I already have it open, and the first thing I wanted to do, let me turn on my sound. We're talking about repetition or repeating logic in our programs. And you guys have already seen some needs for that. One, I think, was when we did that new car price program. If you wanted to test something else, you had to start and run the whole thing all over again to enter stuff. So sometimes it would be nice if we could just keep looping. And I wanted to show you some repetition activities to kind of think about. Come on, YouTube. This one's kind of mean. So they're playing musical chairs, right? They're actually very mean to the little boy. But that's not the important thing. They do really good after. They're very nice to him. Now, with musical chairs, when you play this game, you have one less chair than what you need, right? That's one of the rules. The other rule is you keep walking around the chair while the music is playing, right? And these guys, I like the way they're kind of making it memorable. Oops, what does that do? I don't know. We don't know what those rules are. Oh, we know that that's no good. Okay, so there's lots of YouTube videos with musical chairs that end in that way out there if you want to watch any of them. Something about musical chairs just seems to get people a little carried away. But what's our looping condition? What's our condition for those people to keep walking around the chair? The music's playing. And then what's our condition for them to try try to grab the chair.
Or knock somebody down.
The music stops, right? So while the music's playing, we're going to be performing this activity, walking around the chairs. Once it stops, we're going to try to grab one. Let's look at another looping activity that's not nearly as exciting.
Right.
So that gets scary.
I was past the ad, but then I must have messed it up. Okay, so this thing is going to do some looping, right? So what's our condition for this robot to keep moving these items? Yeah, as long as there are some, right? We're just going to pick it up and move it over to the other belt. So notice what's going on with that robot. To us, it's not a lot, but there's a lot of code there, right? To make him suck up that piece and then move it over and set it on that other conveyor belt. And they're very nicely arranged. So he does have some code, you know, is this the first one? Put it over to one side. If it's the second one, over to the other. So these are all of his arms and legs and things like that that are moving to handle this movement. So that robot is repeating these instructions over and over. And as long as there are pieces coming down this assembly line, he'll keep doing it. It's not very exciting. He's not going to do much different. Here's the screen then that they're looking at, the programmers or developers or monitors watching the robot. And they're seeing everything that they're picking up at the geometric, and then they're getting measurements and all sorts of things for it as it's going. So it's doing a lot more than what we can see just in the movement. But it's some repeating code, right? It has to repeat over and over until that job is done. And that's what we need to be able to do with our programs, some ways more importantly than others. So that's what we want to do, is be able to repeat instructions. So last chapter, we were looking at if statements. We said in a flow chart, we're going to have a decision diamond that says a condition. And out of the decision diamond, we're going to have a true path and a false path for what code to execute based on the outcome of that if statement. Now, looping logic uses the same decision diamond. We still have to make a decision, right? In our first video, it was, is the music still playing? In our second one, it was, are there still circly things coming down the assembly line? So either way, we still had a decision to make. So this flow chart kind of shows that. Notice how it's a little different than just a standard if statement. First of all, we've got some data here, and we're going to make a decision based on that data. In this loop right here, if our answer is no, we're going to do some process and come and check again. Are we out of data? No, process it. Are we out of data? No, process it. When we're finally out of data, we'll be done and we'll exit our loop. So notice this looping structure in our flow chart. A looping structure is usually indicated by an arrow that goes backwards, that goes up in our flow chart. So now we see, oh, this little process right here is going to keep repeating until our decision comes up with a yes. The other half of that flow chart is just an if statement. It's not, it doesn't do any looping. But notice we have to look kind of carefully to be sure. So my condition. Last chapter, I drove you crazy saying what matters with an if statement is the condition. You saw all sorts of test questions and short answer questions that asked you, is this condition going to result in true or false? Is this condition the same as that condition? Start getting the idea that the condition itself is really important. And it is in looping also. So our condition, just like with the if statement, results in a Boolean value, true or false. We can use our relational operators, less than or equal to, greater than or equal to, and not equal to. Our condition, just like with an if statement, still has to have two sides, the left operand and the right operand. We can use variables, we can use literals and strings and numbers, and anything we want in that condition. Now, a few more terms for looping. One iteration is an execution of the loop body. So I would say in musical chairs, an iteration is one time around the chairs. And then you're going to decide whether to keep going or not. Looking at our robot, an iteration occurred every time it picked up one of the round circles. It measured it, it decided what to do with it, and set it down. Then when it picked up another one, that was a new iteration. Each time we go through our loop, we iterate. The loop body is the code that executes if our loop condition is true. So for musical chairs, it would just be walk around again. So we can see that pretty easily. Now, an infinite loop is something that we need to be aware of. An infinite loop is a loop that's coded improperly and it runs forever. It never ends. That's very bad. And if you've ever been in front of a computer that just went to a circle and you couldn't get it back, and sometimes you had to even shut it off, it might have been an infinite loop in one of the applications that you're running. So that always uses a lot of processor time and can lock up your machine. Now we can have different types of loops, so we'll be talking about those. First is a pretest loop. Now in a pretest loop, I'm gonna, in my code, check a condition before I do anything, before my loop begins. So let's look at this flow chart. We input a number, we check, is that number valid? Like say we wanted it to be between 1 and 10. Is it between 1 and 10? If it's not, we're gonna just input a number again and see if it's valid, all right? Now, if it is finally valid, we're gonna process it and do whatever we want. Now, this is a pretest loop because we check for valid input before our loop body begins. We don't have much of a loop body there, but we keep checking. We're going to ask for the number first. Now, here's pseudocode for that kind of thing. In pseudocode, we're usually going to indicate a looping structure with this keyword while. And then we're going to end our while statement to show what code is in the loop body. So in this example, we have a while statement. Its condition is while a number is not valid, we're going to ask for another number and read it in. Then while the number's not valid, we'll ask for another one. So we're going to have some other code in that if statement body to check that number. Now a post-test loop is a little different, but not a lot. In a post-test loop, we ask for input and then check to see if it's valid. If it's not, we ask for input and check to see if it's valid. This looks really similar, but in our code, it can be just a little bit different. In our code, we have a different keyword. We say repeat this stuff until this condition is met. So notice how we're going to do this code in our loop body no matter what the first time. So our post-test loop, our code body will always be executed at least one time. This is another example of how we can do a post-test loop, the do while statement. So different syntaxes are available in different languages. So repeat until is like a Visual Basic kind of thing. Do while is like a C# sort of construct. But as a programmer, you want to be able to look at that code and know what's going on, really no matter what language it is. Now we could also have nested loops, where we have loops within other loops. This loop was my awful if statement at the end of our if statement presentation, where I was trying to find a parking place. And I was just going from one parking lot to another. If I found a parking place, I stopped. Well, what if I don't ever find one? I've got to loop again, right? And I've got to come back into campus and start my whole thing all over again to look through all my parking lots to try to find one. And if I don't find one, I got to do the whole thing again. So I can have nested loops within my loops. So let's create some loops in Python and see if we can make sense of things. I want to open idle. And I want to create a new file. So let's create a new one. And I'm going to go ahead and save it. Find my folder. I did not name things properly last chapter. I'll name it Chapter 5, Fun with Loops. Now this is going to be our first looping program, so we'll have a few. We're kind of still practicing on our if statement conditions, so if you feel like you don't have a complete handle on that, that's okay, because our looping structures are going to reinforce those concepts and make us practice some more. So let's put a comment here. And I'm going to say this script, I tried not doing the colon so that it wouldn't do that IntelliSense, but it still did. I'm just going to call this looping. Fun with loops. Fun with loops. And we'll say we're going to explore looping. Control tab does better. Keep reminding me. Now I'm just going to write a loop here. I'm not going to put it in a module. I'm not going to do anything. While I was writing that date, I realized it's my son's birthday. So let's just write a loop that, oops, it didn't indent. That reminded me I don't have my colon. So while true, I'm going to print out happy birthday, Sean. And you don't have to say Sean if you know someone else whose birthday it is, that's fine. Now, I am creating an infinite loop here. This is going to be a really bad thing. So let's run it and see what we can do. Let's save this program first. Usually when we're doing looping, we start getting a lot more aware of how often we save, because we can lose changes in things if we do create an infinite loop that we have to cancel out of. So not as easy as it used to be, but it can still happen. So I'm going to run this thing. So I'm saying Python, while this true is true, print out this message. Whoops, mad at me. Do I need an uppercase T? I should have known because it wasn't color coded. There it is. Yeah, is it ever going to end?
Nope.
Never going to end. So yeah, Control C always kills things. But you might have to Control C more than once. But when you Control C, if you scroll down, you should see that keyboard interrupt message. So that created an infinite loop because we used a while true. So let's go find our Python quick reference and update it. I'm going to open Word. Haven't had that thing open in a little while. There might be some other updates we need to do to it. Wow, we haven't had it open in so long. It's not even on my recent stuff. Python quick reference, there it is. Okay, so in our quick reference, the last thing we had added were our if statement structures. So check yours and make sure you have the if else and the if elif stuff. And if you're all good and up to date there, we'll add in our while loop.
for our while loop, our syntax, if you noticed, is exactly the same as our if statement, except that we use that word while instead of the keyword if. Other than that, it's exactly the same. So this is going to be a repetition structure. And I'll put in parentheses, looping. Now, if the condition is true, the loop body is executed. Do you want to put the loop body in here? I will. I'll indent a little bit and say loop body. I'll do a couple loop body. Now in our pseudocode, we saw there was an end while statement. We don't have that in Python. In Python, as soon as we outdent, we quit indenting under our while statement, Python will know that's the end of our loop body. So all of our indented code under our while condition is our loop. So let's add a little bit more to our loop body. Right now, all it does is wish Sean a happy birthday. I'll tell him, he'll be glad. He had a really rough day yesterday. I ordered him AirPods because he's spoiled, and they got stolen before he got home. But then he found them in the end. It was okay. So we think the FedEx guy was going to abscond with them. Since they got reported, they got delivered. So it's okay. Got them. So how could we do something in our loop to end? Could we ask the user if they want to continue? Let's try something like, we would need an input statement. So let's have a variable called answer, and we'll use it in an input statement, and we'll say, do you want to end the loop? And we'll say y to end. So is that enough? Can you run it? Feels like I'm missing something. What do you think? Let's check. Run it. Save it first. Is it missing something? I'll say, no, I don't want to end. No. Now, yes, I do. Well, my yes doesn't do anything. Shouldn't that stop it? What, do we as programmers have to make that happen? Oh, we as programmers better make that happen. Let's Control C out of this because we didn't add in our code. So we're asking our user if they want to stop to put in a Y. So we should say if answer equals, I'll use double quotes, Y, we want to break out of our loop. Now I'm going to leave mine up there for a second so people still typing. If yours is ready, go ahead and try it and see if that works a little better. Just asking the question didn't help us much. Still trouble? Oh, okay.
Yeah, it's not ending, but it's giving a break to, well, it works.
It should work. Let's try.
I was entering yes instead of just Y.
Oh, our if statement didn't care about that, did it? So it does end. Now that brings up an important point though. We might want to do something like check for an upper and a lowercase y. In our next chapter, we'll be seeing some functions that would let us turn that to lowercase so we could be sure we had a lowercase variable to work with. But let's add that to our notes. We need to add that break keyword. So break breaks out of a loop body. Try to get Word to quit making them uppercase on me. Now this while loop that we're looking at is good for these kind of loops that we're working on, where we're saying, while they haven't entered a no, go ahead and print this out. Or while the music is playing, play musical chairs. But we have a lot of different kinds of conditions that we might need to be concerned about. Let me find a program here that I'd like for us to write. Okay, now in this one that we've been working on, we were just kind of messing around with our looping, not really doing a super good job because we just wanted to see some things. Now, I showed you the break statement because it's important for you to know that you can break out of a loop. Now that I've shown it to you, I'm going to tell you, don't use it, right? So this structure here that I have set up is awful. This is a game loop. So it's fine for a game because this is how we program games. You know, while true, we throw it into an infinite loop until the player presses escape or exit or whatever they do to get out of the game. But we don't do that for business type programs. For business type programs, if we have an actual condition that we know is going to control our loop, we use that. We don't like the break statement because it alters the flow of the program. If I have this break statement in here and I have a whole bunch of code around it, it could be real easy for other programmers that come along to miss that and to not realize that there is a statement that alters the flow of execution in that loop. So we try to not use those kinds of statements, break and continue. And then there actually is a statement called go to that back in the 70s programmers used all the time because they could just say, go it over here, now go to over there, and it worked great. And it was awful to try to keep those programs running over time. So we try to stay away from those kinds of things. Let's comment this one out and start another one. So I'm just going to move my 3 single quotes down to under our code that we had created. Now I want to leave that code in there for you to refer back to it, but if it's just going to be confusing to you, you know, get rid of it. Now we didn't create any modules in that program. In this one, I would like to. So the first thing I'm going to do is set up my main. And in my main, I'm going to call, let's see, this program, we're going to ask the user to type in a number greater than 10. And if they do, we're going to end our loop. But if they don't, we're going to ask them to enter a number that is greater than 10 again, kind of to make them do what we want. So the first thing we're going to call is our input, and I'll call it input number. Now I want to declare my input number before my main. And as we work on this, we might see some variables that we need to declare, and we might see some things that we need to declare as globals. First, I'm going to start with a variable named valid, and it's going to be a Boolean, and I'm going to start out with it having a value of false. Now, in our while loop, we're going to say while not valid. Notice we just created that valid variable, and we can use it now in our loop. We're going to ask the user to input a number. Number equals an integer from input, and we want our prompt to say something nice like, please enter a number greater than 10. Now, if our number is greater than 10, let's print out a nice message. Well, first, we're going to change our valid to be true. And then we'll print a debugging message. And we'll say something like, the Boolean was set to true. The loop should end. I want to have an else condition. So I'm going to say else, let's print last line of loop body. The condition will be evaluated or eval. Now I want a line of code to print out a message that's outside of this if statement. So I'm going to backspace. And I also want it to be outside of our while loop. So I'm going to backspace again. Now, because this print statement is on the same level as the while loop, it's outside of that loop body. So we're going to say loop ended. The number is, and then we're going to add our number to our output message. And I didn't do a lot of modules, kind of shoved everything there in our input module, so we don't need any global variables or anything. That's good. Now, like I said, if you're ready, you could go ahead and try it and kind of see what it does, see if you think that's what it should do.
Need to call main.
Do we need to call main? Again, that needs to be at our highest level, so it needs to start in column 1. Call our main, which calls our input number, which does all of our work. So I'm going to run this. Please enter a number greater than 10. I'm going to do 8 first. And it says, oh, last line of loop body, the condition will be evaluated. They didn't do it right. I'm going to do 1 because I'm dumb. Nope, still didn't work. So what about 10?
It's saying the same parts is invalid on mine.
Yeah, because you have the colon that's inside of it.
Okay, please enter a number greater than 10. Okay, 11. Okay, in 11 we get our message. The Boolean was set to true. The loop should end. Our loop ends. And then we see our final message that our loop ended. The number is 11. Now let's go back and put some comments on that code. So first, our valid equals false. This looks like something really meaningful. All it is valid is our variable name, and it is a Boolean. So it's set to false. So it's no sort of magic programming or anything. We just used valid as our variable name, using it as a switch or a flag to tell us whether our input was valid or not. Now the next line of code begins a loop. Run the loop while valid equals false. Has to be the opposite of C# with true and false. Now our first line within our loop, we're reading in a number from the console, and we're saving it into our number variable. I can't type. Then we're checking our number to see if it's greater than 10, like we asked. Does number meet our criteria? If so, set our valid variable to true, because we're good, it's valid, and print out our message. Now, this is one of those areas where if we didn't care about burning down trees, you might want to print out this code and draw some lines to kind of remind yourself where those different levels are of indentation. So if it's not making sense to you that this stuff that's indented is the if statement body or the else clause body, before you leave, print it out so you can draw some lines and kind of do the paragraph notation like you would do and say, oh, this is the end of that statement. Because it's like everybody says, oh, it makes Python so easy to code, and it does, because you don't have to worry about a lot of weird characters or anything like that. But it also makes it a little bit tough because you don't exactly know where something ended, depending on what you're looking at. All right, any questions about that one?
Is this, what chapter is this in our Python book?
Let's check. It is,
Sorry to interrupt.
no, that's fine. I wanted to remind everybody about that.
I have the book here.
It's actually chapter 5 in both books.
Okay.
No, it's not. I lied. Chapter 4 in your Python book. So in your Python book, chapter 3 and 4 are both about looping structures. So you want to take a look at both of those chapters. They do have a lot of information in that book for us about it. So today we're just going to look at while loops. Let's do one more. Let me find it. Here it is. Okay, I'm happy with this file. I'm going to save it and create a new one. New file. And I want to save this one. And I'm going to name this one Chapter 5 Sum, as in addition, loop. Bless you, bless you, bless you. So in this program, or Python script, we're going to ask the user for numbers, and we're just going to add them all up. So every number they give us, we're going to add it to this ongoing sum, this running total basically, and then we'll tell them what the total was when we're done. So I'm going to say prompt, why I keep jumping around, prompt for a number, add it to a running total. Now for this one, we're going to try to use some modules. So we're going to declare our variables. We need a variable named number, just like our last one. We're going to call our running total sum, but it's highlighted in purple. So it's like a keyword to Python. So I guess I'll name it total instead. And then I'm going to count how many numbers the user enters to. The reason I'm going to do that is because I'm probably going to want to add in some code to take an average of all of these numbers, just because that's a really good thing to do when we're working with looping. So in this program, we're going to have our input number. We are also going to have, I'm going to go ahead and type in like an outline of all the different methods or modules that we'll have. And Python might get a little mad at us, but we're going to just go ahead and outline anyways. Now, in our input, we could do our looping, but let's try to declare a different module that's going to be our loop for that number. And then I want one more that's going to be our output for our numbers. Then I'll put my main. And in my main, I'll just go ahead and say I'm going to call input number and loop number, and then finally output number. And before I forget, I'll go ahead and call my main. I like to forget because it makes you guys yell it at me and then you remember. Okay, so let's code our input number. In our input number module, we're going to prompt our user for a number. So I need to use that global keyword that we're going to be updating our number variable. And then I'm going to use our number variable to hold the output from an input statement. Now, in this, we're going to say, please enter a number. But we'd like to use a special character to tell the user that they can put that in when they want to end this loop. It needs to be a number because we're converting it to an integer. So what kind of number do you think would be safe to be like that terminal signal to terminate this loop? We could make it be like -99, something. Does that sound safe? You want to do 0? 0 would be good. Let's do 0. Okay, so we'll say 0 to exit. Yeah, because otherwise they're not doing anything with it. Now let's go to our loop. She's giving me go to bed. Here's our loop. In our loop, we're going to say while our number that we just got input is not equal to 0. We're going to add to our count. Now, last week we were talking about these shortcut math statements that we could use. This is plus equal. So I'm going to put a comment that says this is the same as count equal count plus 1. It's just a shorthand way of doing that. Now, in our while loop, again, we don't have 0 here. We're going to print out a message. Say you entered number. And then we're going to output that number they entered. And then we're going to add that number to our total. So that line is the same as total equals total plus number. And then the last thing we need to do in our loop statement is prompt the user for a new number. So I can copy this line of code, or I could call our input number statement again. Which would be better? Input number. Yup, yupper. Sounds good. Okay, now in our output, I'm going to put one line of code, print, output, because I want to test this program before we code this whole output module. I have some students that can write a whole program that's lots and lots of lines of code and then have it work right the very first time. But I am not that kind of programmer. I like to test it. Okay, let's run it. Please enter a number 0 to exit. So I'll put 15. Oh, it crashed like crazy.
Oh, Lord have mercy. You didn't put anything for,
Oh, it's mad about our count.
yeah.
Do I need that global statement? Let's do it. In our loop number, we need to say that we're going to update global variable count and total. It doesn't like what?
I do too.
Well, now I've got invalid syntax in my second step at the input.
So remember, you can use this format menu up here to undent and dedent stuff if it's messed up that way.
Which one do you pick?
It depends on what your problem is. So you could do dedent to get it all the way back to the margin and then indent.
Oh, like for each line.
Yeah, or for each group. Depends on how it's set up. If your whole group is the same, you could do that whole group.
I always have a problem when I press close parentheses somewhere in the loop.
Yeah, or if you forget to put the colon after the parenthesis, that's my big one.
Like where it's got string, we've
It
got.
wasn't intended wrong.
Oh, good, good. Okay, so you don't have to redo it all. Okay, I'm gonna try again because I've got that global statement in. Oh, you entered number 10. That's true. I'm gonna do 15. That looks good. At the very top, I'll show you. Right here in our loop number. That's okay if you typed in some negative numbers.
Oh, yeah, it does. It likes it all.
Okay,
Takes it? How does it take it if you can't go below 0?
You just can't do zero. Zero itself, what is it?
so let's fix our output. Now, we want to tell them, instead of this word output here, let's output maybe a message, the total of all the numbers is. And then after that, we want to print out our total as a string. Now, I'm thinking we shouldn't need that global keyword here because we're not updating any of these variables, we're just using them. Next, we're going to print out our count and say count space numbers were entered. And then finally, just like I was saying, we're going to calculate the average. The average of the numbers is. And what we want to print out here is our total divided by our count. So I can do that math in that print statement, or we could have created a variable that held that average if we wanted to keep it in a variable. Now, if you're set, go ahead and try it. See if it's all working. I'll put my 0 in, and I should get my total, and it looks right. 3 numbers were entered. Now, let's look at some common errors for a sum like this. It seems like logically our code is really tight. Everything looks good. If you look at our output, notice some important things. We didn't count the 0. That's important. It's a real common logic error or bug for people to count this number that ends their loop. We don't want to do that. That would give us an invalid average, right? What else? We didn't count it. So it didn't affect our average. If we were using a non-zero number as a termination, we would see a huge effect if we'd accidentally added that to our total. With our using 0, we can't see as much of an impact if we accidentally add it. But this is a really common algorithm that we have to do as programmers, adding things up, checking the checking account balance, checking their savings account balance, checking it against other things. So just something that we have to do quite often. Did you put that one in? Let's see, let me find the code. That print statement.
Yeah, I put that in.
You want to take over the screen? Go ahead and share with us and let's see what's going on.
Oh, never mind.
There you are. Hang on. Okay, now that's better. All right. That looks beautiful. And it's not doing that last one.
Where? Oh, I see.
Got to put your 0 in.
Yeah.
Okay. Now, and one question, why is it asking for another number? Shouldn't it be over at that point?
Oh.
Do you think you just ran it again?
And just see if that.
Oh. Oh.
Now try it. And then do that.
It's okay. Now, this program looks great. I just want to use it as an example. Notice how the numbers are right up against that prompt. Your first couple of Python programs, I didn't really count off for that, but I will.
For what? I didn't.
For these numbers being squashed right up against the prompt, because there needs to be a space there.
Space at the beginning of it, so it's like.
Yeah, it's spaced over here, but not at the end. So I would definitely count off for that one. See how there's no space at the end of that prompt.
Oh, in the
So it's
green
just-
part where
Uh-huh.
before you.
Yeah.
did the-
So far I haven't really, criticized you for your output like that, but I will be beginning. I don't want to discourage you when you're just getting started, but now I will. What's this?
Okay.
Push that hammer down.
Mine just gave me a whole bunch of bad code. I got.
Mine's not doing the math.
Uh-oh.
What did I do? We're not doing.
Oh, yeah.
Okay, Rebecca, release that thing and we'll get, ooh, look, she fixed it. It looks nice. Release that thing and we'll get somebody else up here because you're fixed. Okay, show us.
Oh my gosh, I did.
Did you guys find it? Okay, show me another problem.
I got about 3.
Let's see them. We'll fix them.
Denise, you're good.
It's saying,
Hold
so
on,
declaring, what is it?
Oh my God.
Oh, I should have read. Yeah. Interesting to see what happens.
Okay, so
Never
hold
mind.
on,
I figured.
never mind. I don't have this thing set up.
Oh, okay.
So I'm sorry, and I don't want to take up your.
Oh, that's all right. I'll figure it out.
So.
Go ahead.
Oh, no, I'm sorry. So is that correct? Oh, God, you have.
So this program, I like this program, but I think I want to change it. I want to make it where we only let them enter 10 numbers. So instead of having this 0 to terminate our loop, we're going to control it ourselves. So let's copy this code. I'm going to Control A to select it all and Control C to copy. Yeah, and you can copy it however you want, but I'm just going to save and then tell idle I want a new file and paste it.
And then paste it on the file.
Mhm.
What should we name the new file?
Control A, Control C, new file, Control V.
I got it.
Got it?
That's a lot of letters.
Control A, select all. Control C to copy it all.
Save it as.
Let's save this one as some loop with count. Let me get back to that right spot. So I'm going to be chapter 5, sum loop with count. So we already had a counter in this program. I'm going to change our script name up here. And so now instead of saying prompt for a number, I'm going to say prompt for, let's say 3 numbers. Maybe in our production environment, we'll ask for 10, but for our testing, we only want 3, because otherwise we'll be here forever. So we want to make sure that that doesn't happen. So I'm going to add a new variable, limit, and we'll set it to 3. So what does that mean when I make it all caps like that? Do you remember? Can you remember? Anybody? Constant. And since Python doesn't really have constant variables, we just name it with all uppercase letters and say, we're not going to change it, but we could. Now, I'm looking at things here. I'm like, well, this is working okay, but I think we need to work mostly with our loop number module, because right now we're looking for this 0 to exit in our while loop, and we want to change this. So we want to say while count is less than or equal to our limit.
And you have to make sure the limit is capitalized since you.
Yeah, since we made our variable name capital.
But in the green between the parentheses, does any of those letters matter for capitalized? Is that
As long as you're within those double quotes, it doesn't matter.
perfect?
Just your string. Exactly. Okay, so this is pretty well going to fix it, because all we really needed to change, we've already changed. But there's a couple of things we should fix up a little bit. First of all, in our prompt, I'm going to make it just say, please enter a number, and I'm going to get rid of the 0 to exit. And that should be the only place I need to change that one, isn't it? All right, let's try running it then. So here's my first number, 10, 20, 30. Please enter a number, 40, 50. Oh, it finally stopped. Yeah, like 5. Is it 5? That's weird. Let's look at it. Why would that be? Well, our first number we're getting input from our main. So let's take a look at that. Do we need to change it? So our main says call input number. In input number, we ask for a number. Then we go into our loop number and we add 1.
I'm down in the main, you don't have limit at the bottom. Does that matter?
Shouldn't matter.
Okay.
So we need to do some debugging. So let's copy this into that utility that lets us monitor our code, right? So Control A again, Control C, and let's open a web browser.
I think this count starts on 0.
I want to go visualize it. So let's go visualize Python. Make sure you're with us so that you can help people remember this website. I want to paste my code. Yeah, Python tutor is what should come up. Visualize Python is what I typed in. Now, this program is big. It's not like huge, but it's pretty big for us. So if we step through the code using this website,
Oh,
we should be able to figure out what's going on and what's wrong with it.
it's the validator like in web development.
No, it's not. No, no. No. No, you're fine. But I don't do web development, so no, it's not. Validator in web is just making sure that you don't have any bad links. This is actually running your code and letting you step through it and making sure that all your links are
Syntax is
valid.
correct, you got all your, everything's open and closed and everything written right, yeah.
It's just a syntax checker. Because remember, HTML is just markup language, so there isn't any execution going on. It's just displaying it, using it. So it's a little different, but a little is similar. Let's visualize it.
I'm finding my mistake.
No, it's fine. Not a mistake, you're right, it's very similar. Now I'm starting out on the ending triple quotes because Python saw that that was the end of this little block comment. Remember, as we press forward, we should see it read through our code, finding all of our different modules. And then finally, it gets down to that spot where we say run the main, and it actually starts running our main. So as it read through all of our different modules, it built all of this stuff in memory. Here's all our different variables. Here's all our different modules and where they are. Do you see all those things getting allocated? Makes sense, it's all going on? Now let's continue. So let's do forward in our main. So the first thing that happens is it should execute our input number module. Yep, so now we know it's going to execute that module. We tell it that number is global, and we don't really see anything happen with that because there really isn't anything for it to visualize us. But now we see our input statement, and right below where I am, it's got my prompt. So let's type a number in, 15, and submit.
Return value none. Why did it say return value none?
Because we didn't return anything.
Oh.
So we're okay. So that's good. So now we got our number. It's minus 15. You can look over here at your memory display and see your number in that number variable. So let's keep going forward. We go back to our main, and our main says, call loop number now. So now we should be at the beginning of loop number. And it's going to declare our globals and go into our while loop. Now, while count is less than or equal our limit. Right now, count is 0, our limit is 3. So that condition is true. We should go into our loop and execute our loop body. So let's click forward, and we should see our loop body begin to execute. We're going to see our count get upped. Now it's 1. We should see the output that we entered our number 15, and remember it's up at the very top. Keep going. We should see our total, have our number added to it, and then we should input another new number. Now I'm going to type another number. This one I'm going to do 20. And I want to go back to my main and call my loop number. My while statement was true again. I just entered the second number, and now I'm going to update my count to be 2. It's going to ask for another number. Mm-hmm.
If you realize you need a grammatical error, can you fix it within the code on the left?
You have to click that edit this code to be able to change it, but you can. Mm-hmm.
So what, when we put limit,
Mm-hmm,
and the limit was 3.
mm-hmm.
I was under the understanding that that meant that you could only run this 3 times.
That's why we're looking to see why is it running more than 3 times? Because you are right on.
Okay.
We
I
don't
was
know
like,
why.
"Am I wrong?"
Nope, you're right. Why is it running more than 3 times?
It's saying something is wrong with, not that something's like wrong with my code.
Uh-huh.
It's pointing to my output.
Oh, yeah.
It's like, it's running and it keeps running and it keeps running, but it's just kind of like, hey.
It's stopping. Now, our count and our limit are both 3. So we're ready to end that loop, right? Our while loop. But we have less than or equal as our condition. So is it really going to end? I'm going to type in another number. And go again into our loop. And it executed our loop again because we have less than or equal.
Output is not.
Just less than. So I feel like that's a good thing to change. Now, as you use this visualizer, notice how it's jumping around through your code. The more comfortable you can get with it, the more comfortable you can feel with being able to tell what's going on behind the scenes, the easier it'll be for you to debug problems. And that'll hold true in other programming languages because they all have different tools that you can use like this to visualize what's going on. Okay, I like that idea. Let's go back to our code and change this to just be less than. Now it does 4, so it still does 1 too many, huh? So is it because we have this original call from our main? Let's get rid of that. And then if I do that, I'm going to move my input number call to the beginning of this while loop.
Wait, what did we do? Sorry.
I just commented out the call to input number in our main. And I'm going to move the call in our while loop to the beginning of our while loop. And then I'm going to get the spacing correct. Now, is that going to fix it? Let's try it and see. I commented out the input number call in our main, and I moved it in our while loop.
Yes.
So 1, 2, 3, and it stopped.
What did it didn't do that 3?
So check and see what you've got different.
Yes.
So when we first started, we were going to, with our previous program, we didn't care about how many numbers had been input. So we just asked for 1. In this version of our program, bless you, we do care. So we're not going to ask for a number unless we're in our while loop and we know for sure we need 1. Right? So just notice how that small change affected our logics to whether it was working right or not. Is it working?
Mm.
You guys got it?
Yep.
Go back there, back there.
I should speak for all.
You're fine. Now, what if I ask you to output the number that they entered and the square of the number they entered? Another print? Or we could add it to this print. Let's just add it to that one. Let's. Yeah. So I'm going to put a plus to add more. The number squared is, and then a plus str number times number. Now I'm going to do some cheaty math like that for squaring instead of using the power function, because we haven't learned the power function yet. We'll learn the Python math functions here really soon. But until then, let's not get into it. TD.
Do you have a space between the issues? You always have to put the spaces between things like pluses
it's not
and negatives.
Yeah,
Okay. So it won't work if you don't.
it'll be all squished up.
It'll just be smushed and
That's hard to read.
She's gonna start.
If we smush it, you don't want.
I'll get mad.
Bring out the
I'll just be like, ew, that's ugly.
Ew.
Let's run it. Because I don't have pretty websites that I can grade. So let's enter a number. I love the pretty websites. I'm jealous. 1, 2, 3. And then we should see for each of the numbers that we enter, now we see our number squared. So we've got all that stuff happening. Now our total and our average and stuff shouldn't be affected by that. Does it work?
I accidentally forgot to put the plus after the.
Next time, we're going to look at for loops. So for loops are another syntax we can use for looping. So if you're working on the short answer questions for this chapter, and you see any that are asking you about for loops, you might want to wait on those ones until next time after we've had a chance to talk about them.
Or loops like the number 4 or
FOR. So we see while loops, but that's all we've looked at so far. Now, in a while loop, notice some things about looping. Our 3 things we've got to have. 1, a condition for our loop. So that keeps track of everything. Looking at this while loop, we also need like some sort of control variable. And then we usually need to set an ending condition or update the control variable. I'll put that. So if you look at the loops that we've created using the while syntax, in this example, our control variable is count, because that's the one that's in our condition that we update within the loop that would make our loop end. Now, some people would look at this and say, no, it's limit. No, limit is just the value we're comparing our loop control variable to. So count is what's actually controlling this loop. We're adding to it. We're making sure that the loop ends when count gets to a certain value. So these 3 things are important, and they'll help us convert to for loops so that we can use those next time. Let's take a look at those chapter 5 questions real quick. The chapter 4 ones, I'm going to save this and close out of it. If you look at your grade, you'll notice, or if I look at everybody's grades, I notice we have a whole lot of A's, which is great. But we do have some grades that are falling because it's important to turn in all of the little assignments. So each one, points-wise, might not seem like that big of a deal, but they really add up and have an impact on your grade. So if yours is not an A, take a look at it and think, why, what have I done? What's the matter? It might just be that you got sick or something that you can't help. But get with me if you want to so we can figure out any sort of remediation, because we mostly have A's.
Can I print out this PowerPoint?
Sure. Yeah, you guys can print any of those out you want. I'm going to go into the chapter 5 review questions and see if it's going to load. There it is. So I'm going to put my name in. And I'm going to be this test student, so I will have trouble submitting this at the end, but at least I can go with you a little bit. Okay, question number 1. Let me find them. Chapter 5. Review. Okay, so answer question number 1. In our book, it says the counter variable in a for loop. Oops, I told you not to do for loops. And then there's other functions that we haven't talked about. We can do number 3. I can tell you what that one is. Do you think that's to validate data? We better check. Because it could be range check. You know how our book is. So I want to look at types of loops. Talking about those pre-test loops and the post-test loops. But they're going to have their special way of referring to these things. Yeah, you'll want to go through some of them because they have some really good stuff. It must be after both kinds of loops. I'm not seeing it. You guys are probably finding it. Doesn't like me. Here we are. Now, when we used the 0 to control our loop, that was a sentinel. So that 0 was our sentinel character that we were using to end our loop if the user entered it. So we can use that sentinel controlled loop for all sorts of different things. And then we have data validation. So I think I was actually right, validating our data. Now, in the textbook, they talk about some different functions. We've used the int function in Python a lot, so you know that converts our data to an integer. So most of the functions that they'll be talking about in this chapter are ones that we have used. Oh, so I'm going to go back to that. Question number 4. Let me get to it again. Number 3, to validate data means to ensure they are in the proper range or range check data. I'll take either one. Now we jump to number 13. Let's go see if that looks better. Have fun at work. Oh, and look, you can have the book read it aloud to you, or at least I can. That could put me to sleep at night. Okay, for number 13, can you see this loop on the screen? Let me get to it. So for number 13, we have this loop. Declare number as integer, set number equal to, and then we use repeat until. Whenever we're working with pre-test and post-test loops, we're looking at where the test condition is. In this loop, the test condition is after the body, so it would be a post-test loop. So for number 13, the answer sheet is not right. For B, list the statements in the body of the loop would be the right in the set. And what is the test condition? Would be number equals 0. Okay, now I'm going back to 5A. If number equals 3, indicate whether each of the following statements is true or false. What about A? Number times number greater than or equal to 2 times number. Is that true? That's true. We can finally answer one. What about 5B? 3 times number minus 2 greater than or equal to 7. Is that true? What about 6A? Indicate whether each of the following statements is true or false. A not equal to A space.
False. It's true.
What do you think? Are they equal? Is A the same as A space? No, it's not the same, is it? But we have a not. So is that going to make that statement true? Yes. What about 6B? Is E uppercase equal to E lowercase? So we don't have to worry about anything else. That's false, right? What about 7? In 7, we have N1 equal to ANN, A-N-N, and N2, bless you, is equal to ANN, A-N-N-E. So tell me, is the first one true or false? N1 equal to N2, and, so you should be able to tell me already, false. Because we know they're not equal, and we have an and condition. So we don't have to look at the rest of it. What about B? N1 equal N2, or N1 greater than or equal to AN.
It's true.
That one's true, right? Because N1 is equal to AN. So this side would be true. Good thinking. 7B, true.
Not.
7C, not N1 greater than N2.
I want to say true.
Seems true. Good job. Okay, true or false? The body of a pretest loop must be executed at least once. False. Remember, a pretest loop is where we test the condition before our body. So if our condition is never true, we'll never execute our body.
Oh, okay.
That makes sense.
Mm.
Number 9, the body of a post-test loop will be executed at least once. Right, that one is true, because we're not going to test that condition until the end of the loop. Number 10. It's got all these weird things popping up on me. Stop it. True or false? A counter control loop cannot be constructed using a while statement. Did we make a loop that we controlled with our counter on our last one? So that's false, right? Because we used a while statement with a counter. We controlled it with our counter to make sure it stopped after 3 times, after seeing debugging. Number 11, true or false, a counter control loop cannot be constructed using a repeat until loop. You've not done a repeat until loop, but you can assume that's false, because we can probably do just about anything we want to if we do the code right. Stop it. And then number 12, the following statement is valid. Input X is an integer. Okay, we'll say false. Now we're gonna try 13 again. It's in there twice. First time we can't do it. So here's our loop. Is this loop a pre-test or a post-test? Does the condition happen before, pre, or after, post? Post-test. And then 13B, list the statements in the body of the loop. We have our right number statement and set number equal number minus 1. So those two statements are our loop body. And then the last part of 13 is, what is the test condition? And our test condition is number equal 0. And I think our book in this chapter just lost the 2 equal signs. I don't know what they're doing. One more.
What did you get for the first few answers? I don't think we did.
Yeah, some of them we got to come back to next time after we've talked about for loops. Because it started out with all the for loops that we put off. Okay, 14. Give the output of the loop in exercise 13. What is that then going to output?
0.
So here's our write statement inside our loop. So what's it going to write out the first time?
Gonna write out 2 because the number equals 2.
That's right. And then it's going to subtract 1 from it. Is it going to execute the loop again?
Yeah.
Yeah. So what's it going to write out then the second time?
Number equals 1.
Or just the 1? And then we'll subtract again, which will take our number to 0. So we won't execute our loop anymore. So it would output 2 and 1. Oh, there is one more. It was sneaking up on me. I didn't realize. 20. 20 is mean because it makes you look at 19. It says, give the output of the loop in exercise 19. So here is our for loop. So we'll wait on that one till next time. Now, any of these loops, you guys could write the Python code if you wanted to try it. Make sure that you have it right. That's a good way.
And we didn't do the first 13, did we?
Right, so we
Okay, that's
did
what I
not
thought.
do that one. That one we'll leave empty.
We only did 3. Validate. I got validate, right? Didn't we have validate?
Yes, validate. It should be 3. Yeah, we'll do those next time for our for loops.
I do have a question. With the forms, if I press submit, will it save my answers? It just saves
No, if you press submit, it will submit them to the form and then you won't have anything left. So it will save as long as you just close out a canvas. But when you go home, you have to be logged on to your OTC Office 365 account to bring it back up. If you're logged onto your personal one, you're not going to see the answers. It'll still show you the form. Yeah, take pictures. That's a good idea. Or do a screen print. So you could do a screen print if you wanted. Don't submit them because we still have questions to answer unless you answer them. And then you're okay. He probably didn't.
Did you get them all?
No, oh, no, and so, I can't really remember what for.
They're not too bad.
So we ended up doing that,
This, you're just gonna just close out of it, take a picture of it if you want to, and save it for next time, and we'll get it submitted the rest of the way.
Which is why. I kind of- But that was all.
So get out of here, be working on your other assignments, take a look at that Python program, so you can bring questions with you next time if you have them.
Bring what?
Questions about that Python program assignment. Have a great weekend. It was a really short week.
Yeah, well,
I don't like it.
Enjoyed it.
I like parts of it and parts of it I didn't, because I'm
My
like,
parents
what?
were not afraid.
Sometimes they seem longer than long weeks, though.
Yeah. Well, there's web code due on Tuesday. I have to be honest, I'll probably do it between classes on Tuesday because they sign up.